Welcome, everyone. Good afternoon. My name is Naveen Narayanan. I am an engineer in the Android and Java developer experience team at Uber. One of the responsibilities that our team has to maintain as part of the developer experience is to ensure that we optimize the development workflow for our customers, which in this case are the developers at Uber. So this entails, creating tools and solutions that optimize build and test times, all the way down to performance improvements within the IDE. Now, just to get a general sense in the room, who here actually, just raise your hands if you use Intellij or Android Studio as your main IDE for development? As I expected, that's almost like majority of the room. And so this shows how important the IDE has become with our day-to-day development. And so when companies start growing and start adding more code, like code base and increasing their code base in general, IDE performance starts to have a huge impact in our day-to-day development. And so that's the point where our team started recognizing this as an issue and started looking into it and seeing if there are solutions and optimizations we can make within Intellij or within Android Studio to help our developers. So just to give a quick background, Uber today actually has platform-specific monorepos. So that means platforms like Java, Android, iOS, and Go each have their own specific monorepo. Now, with this monorepo, this means we have thousands and thousands of modules and hundreds and thousands of files of source code. Now, to make all of this work, we actually use Buck as our build system. Buck is actually a parallel build system that encourages creating small, reusable modules so that it can basically build these modules in parallel and then finally package them into the APK that we have into our app. So because of this paradigm, our source code in our monorepos are actually thousands of modules with a large source set to follow. And finally, as the Android developer experience team, we also encourage all our engineers to use Intellij, because Intellij is a community-built IDE, so it's really easy to pluginize and extend, and we have the access to the source code to figure out any of the issues that our developers might be experiencing. So given all that, what are some of the initial problems that we saw at Uber? First off, because Intellij is a widely used community-built IDE, each developer has inconsistent setup in their own local machine. Because a lot of, previous to monorepo, we had individual apps in each repository. So the configurations that each developer set up doesn't technically scale when they came into the monorepo ecosystem. So because of this, developers also started experiencing a lot of indexing time issues because, coming into monorepo, you're now merging all the different apps that Uber provides and have to wait for all that source code to be available before you can do any sort of magical things that Intellij allows you to do. In addition to that, any kind of solutions that we built for optimizing the IDE, we always had this one issue where developers just wouldn't update. There's a saying that goes on, which is if a developer doesn't see the fit or have the need to update a specific version, they never do. And so then we now have this long tail of support that we need to give for these older versions of our plugins or tools that we built. And so this made our jobs quite difficult. And needless to say, as we roll things out, we also had zero visibility into seeing what sort of exceptions people were experiencing when we were rolling out these solutions to optimize people's workflows. So we tried to tackle each of these problems individually, starting with inconsistent IDE setup. Now, I just want to quickly give you a graph. So this, on the right side, you can see the default VM options that comes with Intellij. I think this was pulled from 2019.1. And immediately, you can see one of the biggest issues with this, which is the max heap space that is initially set within Intellij is set to 750 megs. Now, when you come to a monorepo, which the repository itself is in the gigabytes, it's impossible for Intellij to scale and index everything related to the app with this small of a setting. And again, as I mentioned, people were coming in from micro repos where they had individual apps, so none of these settings ever impacted them at all. And because IntelliJ is so customizable, people could just modify things on the fly, and everything would just work. But then the issue with this is now you come into monorepo, this introduces things like freezing the IDE, or basically GC overheads, or other sorts of issues that became a huge headache for our team to solve. So needless to say, this definitely did increase our support load that we needed to provide. And so we wanted to tackle this in a more principled approach. And so the first thing we tried to do is to uniform everyone to a singular template. On the right side, you can see is the template that we now actually use actively in our Android monorepo. And again, instantly you can see the heap space has been bumped up to 4 gigs because we need that memory. And because developer local machines now support 16 to 32 gigs of memory, this is not an issue for our developers to basically plunge in 4 gigs into IDE. Now, the way we enforce this is the interesting part. Now, because, as I mentioned, we use Buck as a build system, we actually have a wrapper around the entire build system itself, so that any sort of actions that get executed within your CLI or from your IDE itself go through this wrapper. And so as part of the wrapper, one of the post-processing steps that we do is to actively just go into all your IntelliJ instances and patch these options into your IDE. With this freedom to ensure that we can enforce this level of templating, we actually now have a lot of developers that are all using the same uniform setting. And another interesting thing to look at in the setting is the second last option, which I'm not sure if you folks can read it, is caches.indexerThread count equals 8. Now, this feature is actually not widely public, and we actually found this out by going through, digging through IntelliJ source code. What this flag actually tells IntelliJ is that it can allocate up to the number of threads that it needs to use, or number of cores it needs to use number of threads that it needs to use for indexing your source code. Now, like I mentioned, the local machines that we give to our engineers at Uber are the latest and greatest. And so we wanted to optimize the machine to its fullest potential to mitigate any sort of performance costs that might come from this. So this flag was actually kind of crucial in getting us that stepping stone to improving performance. So with all this, we gained some performance improvements, but nothing significant that we could just clap our hands and be like, we're done with it, that's it, that's the story of indexing times. So we then dug in further and tried to look at what is exactly causing these long and arduous indexing time. So let me just set up a problem statement. Hey, I'm an engineer. I've been tasked with creating this new and shiny, simple feature that we want to introduce into our writer app. So, being that, the boisterous and happy go-to engineer, I already have the idea of what I want to type. What is my feature going to do? All mapped out in my head. And this is the code representation. I'm also a cool and hip engineer. So, of course, I'm going to write this in Kotlin, right? Well, that's the cool thing to do. And so I already have everything ready to go. So the first thing I do is open up our Android monorepo within our IntelliJ. And then I wait. And I keep waiting. And I wait a bit more. And then at some point, I flip my table, just like that image over there. We today, within our Android monorepo, can take up to 5 minutes. And I'll go further into what we do as an optimization, but this 5 minutes of time is basically every engineer just sitting there before they can do anything with their IntelliJ with regards to syntax highlighting or symlinks or anything else besides just using IntelliJ as a glorified text editor. So what is happening? So we tried to look into the flow of what IntelliJ does. So as an engineer, I already do a bug project writer. So as I mentioned, because it's a monorepo, we have multiple apps within our giant repository. So we already have trained our engineers to only project the app that they're working on because we have app-specific teams. I'm an engineer who wants to work on Writer, so I'm only going to bug project Writer. And this already reduces the entire dependency graph to just be narrowed for that app. But even with that level of optimization, we nearly have 250,000 files that have to be indexed when you launch the IDE before the IntelliJ is ready to do any sort of code complete. And so this is where all the cost is eaten, because as an engineer, you're just opening the IDE, I just want to build a simple feature. I only care about my dependents that I use, and I don't want the entire graph, but it's good to have the entire graph for refactorings and other things that I want to do later on. So, but the fact that I have to wait for every single thing to be indexed sucks, and basically is a huge time sink. So what is going on? Why does IntelliJ need this? So one thing we noticed is that IntelliJ actually slows down the more number of modules and files that are introduced in the repository, which makes sense. But the additional fact is the idea that when you have more modules, you're also now recursively traversing through the file system to find the different source files that it needs to process. So this adds on top of the existing cost that's already there with indexing a single source file. In addition, as I mentioned, because we have so many different source files, IntelliJ has to have a large heap space to process all this. So if you don't provide enough memory, you're basically going to have you're going to maximize your heap space, and it's not going to be able to optimize everything properly. And finally, without indexing, you have zero access to any of the IntelliSense, as IntelliJ calls it, which is stuff like syntax highlighting, symbol navigation, or anything else that requires the build to be ready for you to continue development. So clearly, this makes IntelliJ just a glorified text editor until everything is done. But that's not why we use IDE, because if you want a text editor, we use something like Sublime or TextEdit, or Vim, if you're a power user. So then we dug into IntelliJ. We tried to look into it and see what was actually happening. And what we noticed is the file-based index that is being used actually, like I mentioned, recursively visits each child of the directory that's part of the entire project set. So the interesting part to notice here is that it looks at everything except for the projects that are excluded. So that gave us an idea. What if we could trick IntelliJ into thinking that a lot of our project is excluded until things are acquired? And so then we dug in a bit more and saw that in 2017.2, IntelliJ did actually introduce a feature called load and unload modules. So this basically allows the developer to manually go and say, I want these specific modules to be part of my project scope, and then everything else will be automatically excluded. Now, this is great. We can tell our engineers do this, but the issue with this is that now this is the manual process. And the more process you add into development workflows, the slower the workflow becomes. And so we wanted to find a way to automate this entire process. So thus, UberFocus was born. So UberFocus is our coined term for on-demand indexing, which plays around the same term of only indexing things based on the required context. So you might see that this flow looks quite fairly similar to the original flow. So just to quickly go back. But with the addition of a file module loader, which is in between the IntelliJ main thread and indexing. Now, this is where all the magic happens. Basically, if you go through the flow again today, you do a buck project, we instantly lock the entire IntelliJ from running any sort of indexing. So this is to prevent IntelliJ from just randomly indexing the files that we generate and waiting until we tell it to index things at a specific time frame. And so at this point, we generate the project files, IntelliJ is locked up, none of the indexing occurs, and then the only things that get indexed after we unlock the project is just libraries and SDK. And because this is the Android monorepo, of course, we need the Android SDK to be indexed, and we need the Java JDK to be indexed as well. So both of those things are the initial cost that developers will have to eat. But because these things are fairly static and they don't change that often, it indexes once, and then the rest of the events, it's always cached. So it's much faster in recurrent launches. So the interesting part here is now as a developer, when I open a specific source file, that's the event that we use to calculate what are the required dependents that this file that's open in the editor needs for it to finish its symbol, syntax highlighting, symbol linking, and all the other fun stuff that IntelliJ provides. So this is where the file module loader comes in handy. So to go a bit deeper into what file module loader does is that the file module loader actually listens to events all the editor events on the files that are opened. So whenever a file, as a developer, is opened on the editor, it instantly goes, looks at the file, finds its parent module, tries to find the module's dependents, and then load only those modules. So you can see that we use something from Module Manager, which is still in its experimental stages, but has been working in a perfect way for our use cases. So with that, let's go back to my simple feature. So this is the small condensed version of the dependency graph for my simple feature. And so when I open up a specific class in my main my simple feature module, I am then only loading feature A and feature E source files, and none of its dependents. So we're always only looking at one depth level of the dependents. And so now I'm coding, everything is great, but now I want to look at the source file within feature A. Not a problem. The moment you open up feature A, we automatically will load feature B, C, and F, which are the dependents to this module. So, and on this goes. So the great thing about this option is that now we're only indexing things based on the context of what you need. So we're fragmenting that giant 5 minutes of waiting to just smaller chunks, which now can also, better utilize the memory available for IntelliJ, can use more of the threads more effectively, so everything just becomes more performant. So just to give you an example, here's a demo of UberFocus in action. So as I said, you're opening feature A, everything on the left side is already unloaded, and then automatically you can see the bottom bar, indexing is already complete. And so then if I try symbol click into feature A, you can, oh boy. And so yeah, and you can see that as soon as I clicked into feature A, a bunch of other dependents on the left side became unloaded. So this level of automation, is quite effective. And so some of the data that we have is that just for my feature alone, it only took 1.5 seconds for me to finish the entire indexing for working with that feature class that I wanted to work with. And because we're only loading first level dependents, this thing can scale out to X number of sources, thousands of modules, whatever you have it, but it works with a large code base. And we also just reduced the number of files that had to be loaded at one instance to only 1,400, as opposed to the 250,000 that I had to wait for when I first launched my Writer app. So with that, all our engineers are happy. We're all hunky-dory. This is great. Everything is working as we need it. So why isn't this a feature that IntelliJ supports by default? Mainly because there are some limitations. And I'll go one by one with these limitations. First off, find by file or find by class, which is something that folks are really used to when it comes to development, to basically quickly jump over to their source files from different modules, from different libraries, stops working when you don't have the entire graph loaded into memory. And so this kind of level of skipping is now lost as a feature. In addition, anytime when you try to do find usages or you try to do any sort of refactoring, which is like rename, move, or like you change any sort of the method signatures, this feature now stops working as well because, again, IntelliJ doesn't have the entire graph in memory, so it doesn't know who's using what specific classes or methods or modules. And so all of these problems seem grave. And at this point, you might be asking, so then what is the benefit? I get the speed, but I lose all the features that IntelliJ provides. So don't worry, we have solutions to solve those as well. So first off, looking at the find by file or find by class, we actually, because IntelliJ is highly customizable and open source, we can actually custom add our own algorithm to provide the files that should be available for a user when they want to search or go to a specific class. And so what we do is similar to the way we do any sort of patching to IntelliJ, is that after you run any sort of bug project action, in the post-processing, we essentially just dump all the files that should be available for the engineer into a text file, which is then piped into IntelliJ through our IntelliJ plugin, so that when the user tries to do a find usages, it doesn't use IntelliJ's memory or IntelliJ scan to index scan to figure out which files to go to. It now uses our text file to find where those files are with their direct paths, and then navigates to those files. So as you can see, that's a great example on the left side, where you can just type all the files that are available and then just navigate to it. Now, the great thing about this option of customizing the entire algorithm for this is that now we can now include files that previously couldn't be indexed, things like tooling scripts, shell scripts, Python scripts, etc., and now add those as potential searches that users can go to. And so that's where we have an example of ProGuard being something that a user can go to, which previously wouldn't be accessible through IntelliJ. And so people had to open either Sublime on the side or a text editor on the side just to circumnavigate to these sort of tooling scripts. Great. So that's problem 1 solved. Now, problem 2, find usages and refactoring. Now, again, as I mentioned, without having the entire the graph in memory, this becomes impossible for us to run. And so when we introduce this feature, it's absolutely critical that we educate our engineers saying that we are modifying your typical workflows. And so as you can see on the screenshot, we actually have a lot of educational messages. For example, if you do a find usages, we actually do say, hey, the class you're trying to find or the method you're trying to find is actually being used in some other modules that still haven't been loaded. And then we give the option for the engineer to basically click on that option and have that module loaded in addition with the entire graph that's already there. So with this approach, we can now get the existing behavior for people that want to do mass migrations. For example, our mobile platform team usually does this a lot, so they leverage this feature quite often where they need the entire graph in memory. So it's important that we still have this option available so people can make their modifications. And we also, so the way we do this is we intercept any sort of action that comes into IntelliJ through the IntelliJ's action interceptor. And the moment we see the action is either a refactoring action or a find usages action, we instantly pop up a prompt asking the user, hey, do you want to load the other modules that are also dependent on this particular class that you're trying to find or refactor before you commence this action? Now, if you're a power user and you already know that this usage is fairly minimal, then you can just go ahead and ignore it, or the default behavior is to load that memory and then commence the action again. So we added a lot of these optimizations with addition to some workarounds for existing behaviors. So now, given all this is great. We now solve this age-old problem where indexing is an issue. We brought it down to a smaller scope, essentially, based on what the engineer needs to work on. But now, how do we get this rolled out to all our engineers? So this is where we started looking into our rollout strategy. Now, the typical way that most engineers, at least in different companies, if they have their own plugins that they want to roll out, is they set up a VM options or a property flag at the bottom, which, again, I know, apologize for the small size, where you can just point the plugin host to a specific custom URL where you can host all your custom plugins. Now, this is great if the engineer actually reads the prompts or clicks on the button to update, but most engineers don't. And so usually we see an adoption rate within the span of 2 to 3 weeks of only 30 to 40%, which is terrible because we just created an awesome solution, but no one's technically using it or even knows that this solution exists. Email only goes so far, so we needed a better approach. So again, similar to what we do with VM options, we patch everyone. We basically, whenever you run any sort of buck action with regards to working with IntelliJ, we instantly go through all your IntelliJ instances and install our custom plugin. So in this case, we installed the Uber Focus plugin, and because we use Buck, we have our own custom Buck plugin that we also patch in addition to this. So with this, we had a huge win. We noticed that adoption rates, previously which was only 30 to 40%, is now just skyrocketed to basically almost 90% adoption rate. And these are the 2 custom plugins that we have. And this is the data set for 2 weeks. So by having this level of enforcement that we can push up, we now have full control about what our engineers experience with our monorepo and how they perceive a lot of the toolings that we introduce into the ecosystem. So now, given all this, the final issue that we hit is the issue around now that we have all these great features, how do we know that our features are actively working? Like, how do we know they're supporting all the things that need to support? Because we have no way to monitor what's happening once we roll out these plugins. And so this is where we decided to start looking into adding, similar to what we do with any apps today, which is simple. Any sort of exception that happens only within the plugins that we care about, which is our Buck plugin or our Uber Focus plugin, we want to automatically capture the stack trace, the log files, and any other metadata that might help us debug the engineer's issue, and upload it to our ticket tracking system. Now, this is great because this gave us the ability to have a dashboard and track the reliability and crash-free rates for our tools. And it also allowed our developers to send crash reports via the IDE. And finally, all of these tickets came to us. We were able to ticket them, triage them, prioritize them, and it allows us to have a faster feedback loop on our plugin releases. So here's a quick architecture of what we do within our plugin. So basically, what happens is, as IntelliJ today actually does have a default behavior, which is the moment you have a crash, you basically can see a window that shows up with a prompt saying, hey, do you want to send this crash report to the engineer? Now, like I mentioned, the more process you add into development workflows, the slower it becomes. So most engineers prefer not to send those crash reports to us. And so then we drop these issues in the ground. So what we do is we basically add a hook on top of the existing IntelliJ crash reporter and listen to any sort of message events that happen within IntelliJ. Message events is how IntelliJ basically propagates all of its events and messages across the entire system so that each plugin can do things accordingly. And so once we grab these message events, we basically filter it down, only look at the ones that's related to our plugin, add a bunch of metadata, and then fire it off to what we have as in Jira or Fabricator in the backend. And that's where you see the uFlurry backend. I won't get too much into it, but that's the general gist of it. So given all this, what does the future look like? So we're actually planning on open sourcing our two feature sets here, which is Uber Focus, indexing on demand, as well as crash reporting to the general audience, basically for everyone to use. We're building it in such a way that it's not build system dependent. It's agnostic, so it can work with Gradle, it can work with Buck, or any other build system out there, as we're only using the project API that IntelliJ offers so that it abstracts a lot of that dependence away. So with this, a lot of the logic of what modules are required or what modules aren't is already baked into IntelliJ today. So we're just leveraging that existing information and just breaking down the indexing component. Oops. Second, crash reporting. We've been actively looking inside the community to see if there's an actual crash reporting within IntelliJ and couldn't find anything that was well developed. So we are deciding to also introduce that so that if other teams want to use it for their own plugins or they have their own custom plugins, they can go ahead and utilize this feature. So to summarize, basically, let's just quickly go through and see what are all the different things that we did and how we solved them. So first off, because we had a lot of different types of IntelliJ setup, we ensured that every engineer uses the same custom setting through our patching strategy. And the key flags that we set today are the caches.index or threads count, which, as I mentioned earlier, allows us to tell IntelliJ how many threads it should use for indexing alone, and also bump up the max heap space or max heap size that IntelliJ can use when it comes for any sort of action, such as indexing or refactoring or whatnot. In addition, we overall try to improve indexing through on-demand approach, so that only based on what the engineer opens or what their context is, those are the only resources that get loaded in memory. And following up, once we have these tools, how do we ensure adoption. We basically patch everyone. We ensure everyone follows through so that we have faster adoption and faster feedback loop. And finally, we monitor all the incidents and crashes using the crash reporter so that we can ensure that we have stable releases of our plugins. So I think that was fairly quick. So I'll open up the floor for any sort of questions, feedback, or anything that they have questions about. Just feel free to reach out, or you can even talk to me now. We have a booth in the back as well if you want to talk to me after this session. So that's the end of the talk. No, so.